Okay, we'll wrap up the mathy application problems here, looking at two maybe slightly more difficult examples. First one says, write a sine function that has a period of pi over 5 and an amplitude of 6, and it goes through the point 2, 0. So you look at this, and I think initially it sounds really difficult, but they tell you several things right away. It's probably always useful to consider what sine originally looks like. You definitely don't always need to draw this, but I'll just have this here as a reference. We know, for example, that the original amplitude of sine is 1. This problem wants the amplitude to be 6, so that means all I need to do is make my a value equal 6. Okay, that won't be too hard to plug in. At the end it says it has to go through the point 2, 0. Well, I have a point that goes through 0, 0. If I just shift this whole graph 2 units to the right, it's going to work out just fine. Now this is the point where I need to say there are infinitely many functions that could work here. The easiest is going to be taking this and just moving it 2 to the right. So that means my h value has to equal -2. The tough part is going to be dealing with period of pi over 5. So do remember that we have an equation that says the period, so pi over 5, the period has to equal 2 pi over b. We've talked a little bit about why that is, why that works, but the only way that this fraction works, you could think of cross multiplying and dividing. You could just logically think through it. But b would have to equal 10 for this. Okay, so these are kind of the three important things that I need to use. So as I write one of many possibilities, I'd say y equals my amplitude of 6 times sine, and then my b value was 10. Put another parenthesis there, x minus 2. That's going to be one equation that would make this particular question work. That one's not so bad, you just have to take some time to think through it. The other one that I want to look at today is probably a little bit more difficult. Let me erase what I have here. Slide this up. It says write a sine function that rises from a minimum value of y equals 5 at x equals 0 to a maximum value of y equals 25 when x equals 32. This one's going to require just a little bit more work for us. And in this case, I actually want to draw what this thing looks like. So I know, there's my coordinate plane. Wow, curvy lines there. I know that at at 0, 5, I have a minimum. And I know that at 32, 25, I have a maximum. And that also means that, if we think of the symmetry of our sine function, probably right around here I'm going to have another minimum, and that would have to be at 64, 5. Okay, 64 because it's going to be double 32. If this is a length of 32, this also needs to be 32. And then 5 because it's got to match up with the original point right there. So that's kind of the graph that I'm getting there. So I'm going to try and show you how from this picture we can try to figure out what b, a, h, and k should be. The first thing is, there's so many ways that we could start this. I guess I would start by just considering this point right here. That's the point that is halfway between a minimum and a maximum. On the original sine function, that is 0, 0. So I think that's kind of important to note. And we can think through the symmetry of what we see here. It's got to be halfway between 0, 5 and 32, 25. So the coordinates there would have to be 16, right? Right in between 0 and 32. And halfway between 5 and 25 would be 15. So I know what that point is. From there, I can now consider what A, B, H, and K are going to be. And I just need to think through this kind of carefully. The overall change from max to min, 25 to 5, is 20. Half of that is going to be my A value. So I know, I'll do this in purple here, I know that A has to be 10. Okay, take half of the overall change from max to min, that's going to be my A value. That's going to be the overall stretch and shrink that I see. The B value is going to be related to knowing the period. The period is 64. I just need to slide some things over here. Okay, so we have 64 for the period has to equal 2 pi over B. Now, I can go through and show you this in class, but whenever you have this sort of equation, the unknown is in the denominator, this will go to, all you have to do is flip the 64 in the B position. So B has to equal 2 pi over 64. So B would equal pi over 32. Okay, if we look at our graph, this point right here kind of connects to 0, 0. So I shifted 16 to the right and I went 15 up. That means that H has to be, if I went 16 to the right, H is going to be negative 16. And that means K has to equal 15. So just by looking at the overall graph of the function that's been described, comparing it to the original sine function, now I can go ahead and come up with the function that I actually want, which would be y equals, we'd have 10 for A, my B value was pi over 32, we'd have x minus 16, and then on the very end plus 15. Okay, that would describe all the movements, all the transformations needed to take sine and make it meet the requirements of this particular question. So there's a lot going on there. Jot down any questions you have, and we will see you in class.